Welcome everyone, it's Dave Laurie here in Perth. This is just a short webinar, half an hour or so, just to take you through some of the new features in ioGAS. It'll be a mixture of myself and Putra Sadikan presenting. If during the course of the webinar you have some questions, then please feel free to type them into the questions component of the GoToWebinar interface, and when we get to the end of the webinar, if we haven't covered off on the questions, then we'll come back and answer them as best we can. Now, just to get going, we're calling this the 10th anniversary, but those of you who are long-term users of ioGAS will know that we've probably gone past the 10th birthday a bit, but nevertheless, it is what it is. Now, for those of you who are already using GAS and those of you that are licensed but haven't downloaded the new version, we'd very much recommend you do so. The most immediate change when you install the new version is the upgrade to the interface, including the new ribbon bar which runs across the top there. I suppose it's interesting in the 10 or 12 years that GAS has been in the market, and I've always thought that it looked a bit old-fashioned and daggy, but not one user in that time has ever commented on the fact that GAS looked a bit old-fashioned. Nevertheless, we took it upon ourselves to upgrade the look of it a bit, and hence you see the new ribbon toolbar across the top there. Some of the other things which we'll talk about a bit more later on are the fact that the context toolbar, which we used to call the right-hand side toolbar, we can't call it that anymore because in the global settings you can now configure whether that plots on the left or the right-hand side of the software. And there are some other upgrades in there as well. And another one which I think will take the eye of existing users is the default colouring scheme, which is what is visible in that view there. But that is changeable, but I'll come back to that later on. We find that using this new colour scheme after a while becomes much easier on the eye. So that's just a reiteration there of some of the more obvious things that have changed in the interface in the new version. So there's a little screenshot there that shows you where the configuration is in general settings. To put that, well, I was going to call it right-hand side toolbar, to put the context toolbar on the left or right-hand side of the desktop. The other thing now is that toolbar is a bit better organised. It's now dual column, and you can get straight to modes on right click when you click some of the buttons on there, which as you can also see in that screen capture, whereas previously you would just click through the nodes by clicking the button. Now you can right click and just go directly to a mode that you want, which also means that they're conveniently labelled. Now I'm going to hand over to Putra, and he's going to give you about a 10-minute quite comprehensive run through of the new features in the software and how to access it. And when he's finished, I'm going to come back and just emphasize the importance of some of the new features and ways to use them that you may not have thought of. Just let me get this ready. So I'm just going to let this run now, and I'll see you again after Putra in about 10 minutes.
This is a quick overview on some of the new features in ioGAS version 7. In the new interface, all of the functions of the program can now be accessed from the ribbon toolbar, with each ribbon bar representing a collection of similar tools. The home ribbon bar will be the first thing that you see when you open a new file into ioGAS, and most of the basic functions of the program can be found from the Home tab. And you can see how the new features are grouped into separate bands of related functionality. This includes opening and saving a file, and access to select variables, attribute manager, data view, and basic graphs and statistics and map tools. Some commonly used features such as select variables, attribute manager, and data view can also be found in the other ribbon bars, which gives you easy access to those tools no matter which ribbon bar that you're currently in. You can double click on each ribbon bar title to retract it, or double click on it again to expand the ribbon. In the file ribbon bar, you can bring in your files through the usual methods with the icons contained within this band. We've also added the functionality to open a file from an acquired database. And we've also made it possible to add new columns into the file via the Join File menu. And this is based on two files having a shared ID column such as sample number. You can save a checkpoint in the file by clicking on the Save Checkpoint icon. And you can also create a template from this band as well. Opening a template and checkpoint are done from this ribbon bar as well. On the upper right hand corner of the window, we have a quick access toolbar with shortcuts to the help, the attribute legend, and a list of open plot windows. You can also access these functions using some of our new keyboard shortcuts such as Ctrl-L to display legend window, and other useful shortcuts are Alt-H to open up the Home tab, Alt-D to open up the Data tab, and so on. When we make a plot window active, we will bring up a context toolbar, which we used to call the right-hand side toolbar. The context toolbar can now be moved across to the left side of the screen by going to the General Settings dialog, which is found from the Home tab. And in this dialog, you can also set the default coloring scheme that is used in all of your open plots and in the Attribute Manager. This is saved by ioGAS and is retained between sessions. We can now toggle through the state of a toolbar icon, such as a regression line type option by right-clicking on it and choosing the state to go to. So here you can see that Reduce Major Axis Regression has been added as another option of calculating your regression in both scatterplot and scatterplot matrix. Reduce Major Axis Regression is also found as a new option in the Analysis Menu Regression tool. Another example of the Context Toolbar right-click option can be found on the Point Density Cloud Visibility setting. And in this version of ioGAS, we have made it so that point density clouds can be reinterpolated to only the data points that are currently in view. On the ternary plot, we can now center the plot using this icon on the context toolbar. And you may also notice that the data points in this plot have an outline around them, and this can be enabled via the rendering settings dialog found on the context toolbar. In the 2-key box plot, outline around 2-key box plot box are turned on by default. On downhole plot, we now have a scrolling window if you have a number of drill holes selected. So this can display up to 50 plots in a window. You can plot a new single trace by variable downhole plot. And it is now also possible to save your x-axis range, which can be done by going to the plot settings by right-clicking on the plot window and typing in a selected range and saving it. Save ranges configuration can be edited in the element ranges XML file, which is found in your user config folder. This is useful if you want to compare patterns between drill holes for a specific range of values, for example. So let's open a couple more downhole plots. And you can see that the same ranges has been applied to the new downhole plot that we just opened. And lastly, on data view window, you can now color all the cells based on rank percentile value. We have made a number of changes to the calculation diagram and spider plot tool. We'll open another file to show some of these new features. And you can see how I open the file from the Graph tab as opposed from opening it from the File tab or from the Home tab. The new and edit calculation tool interface has been completely reworked, and you can now assign a reference name to an expression, which will allow you to refer to another expression from an expression, thus allowing function-of-function calculations to be run. With these changes, it is now possible for us to run a complex calculation such as a CIPW norm calculation, which relies on the use of nested if and else statements. We have made a couple of variants of the CIPW norm, all of which can be found from the normative terminology provided calculation menu. And we have also created a volumetric version of the calculation, which is used to create the normative terminology form of the QAP classification diagram. The Quick Calc menu now also supports conversion between oxide to element and between units for selected elements. So if we have all of these elements selected in ppm, we can choose to convert them all to percent, or we can choose to convert some of them to oxide. In a spider plot, which can be accessed from the spider ribbon bar, we can now make variables from spider plot normalization values. If we click on this icon on the context toolbar while the window is active, we can add normalized values for each of the selected element as new columns into the file. The resulting columns are named with an abbreviated prefix representing the spider plot name plus the element name. We have made some changes to the way ranked variable maps work, and these are now called variable maps. And you can find this from either the Home tab or the Map tab. And the reason for that being, we can now choose to use other thematic operations. And this includes 10 equal ranges and an absolute times background thematic operation, which can be useful if you're looking at a spider plot normalized columns, such as these ones. So you can see here that the warmer color represents multipliers of the background values that are represented with these variable maps. Diagram menu now allows our users to create diagram access from two separate calculations files. So let's select a couple of columns that were created from separate calculation XML. And as we create a new classification diagram, we can see that this is now possible, and this was not possible to do before in an old version of GAS. And in the edit diagram window, it is now easier to edit polygon or polyline vertex. So after I created a polygon, while we have edit shape active, we just click on a polygon vertex, and you can choose to edit the location easily just by clicking on it and adding a new value. And you can also delete your vertex from this menu as well. And if you're creating a new polyline, if you hold down the A key while you're drawing your polyline, it will add an arrow to the end, which is useful if you want to better annotate your classification diagrams and such. If you have a session containing a large number of open plot windows, one new thing that you can do is to stop ioGAS from updating all of your plots every time you update your attributes. You can pause updates by clicking on this icon on the ribbon bar, and you can choose to let it run when you have the right combinations of plots open. So let's open a number of different plots by opening a template. Templates can now be used with alias data, which converts your alias data on the fly to the required variables. And you can see how it creates a number of new columns in the file, which are oxide columns that we didn't have before in the file. We only had the ppm version of it. And new in this version of ioGAS is also the ability to attribute classified data in diagram as filter groups. So when we do this, you can see that nothing's happening because updating is paused, and you can access attribute by filter on the context toolbar. And the same thing happens if you change other attributes such as color, shape, and size. So as we do that, you can notice that the plots are not updating as we would expect it to be. However, when we turn on resume updates, you can see that all of the attributes, and including the filter group as well, that will have been attributed after you click on resume updates. This concludes a very brief overview video on some of the new features that we have in ioGAS 7. For more information, please refer to our help file or contact us if you have any further questions.
Thanks, Pooja. You may have guessed that Pooja's actually on leave, and so we pre-recorded that. Nevertheless, fairly effective. Now, I just wanted to revisit some of the features that Pooja quickly covered in the run-through. The new color palette is very important because GAS has had a single color palette by default for many years now, so we've upgraded it. Important just to run back though and show you that if you are displeased with the new color palette, under the general settings, you can go and change it back to what it was originally. And when you do that, the new color palette is propagated through all of the open plots, and down through into the data as well. And just to demonstrate that to you, I'm going to flick over into GAS Live and just go into the settings. Oops, sorry, it's going on. Nope. And here are the different color ramps here. So if I go and select original and apply, then it does back propagate through all the other plots. So GAS looks like it always has. There's also a couple of other different color ramps there, including one which is designed for colorblind people. People have often asked us in the past that, gas is very good, but with all of this red, green, blue propagated everywhere when you first started up, if you are colorblind or slightly colorblind, it can be a bit difficult to see what's going on. So we now have this colorblind friendly palette included. And again, if you see there when I press it, it propagates through. So I'll go back to the default again. Just while I'm in here and running GAS Live, I just wanted to show you a couple of other things. The ribbon toolbar, the feedback we've had from it so far has been extremely positive. But one comment is that it takes up quite a bit of the desktop from plotting graphs. So if you double click up on the top of the menu, the ribbon disappears. So it gives you more screen real estate. But if you come back and click on the top menu items, then you get the ribbon back until you click back within the working area. If you want the ribbon toolbar to be docked at all times, then just double click on the menu entry at the top there and they appear and stay there. There's a couple of other new icons over the extreme right hand side. There's a quick access to all of the open windows there. To open up the legend, there's a quick access small button there on the side. And the help file, as usual, the help file is extremely comprehensive and up to date. But to access it now, you click the little question mark over the side there, and it actually opens it in your web browser now, rather than within GAS. So we've upgraded that. So the content is completely comprehensive. It just looks a bit smarter now, a bit neater. It's been tidied up. And of course, we say that your first port of call, if you've got a question about something in GAS and why it does what it does, is to drop by and have a look in there. The other thing is, for those that prefer the old look of GAS, and so where is that?
On the file.
Settings. If you really don't like the ribbon toolbar, it is possible to go back to the original ioGAS toolbar. And of course, we've been working with this version for about 12 months now. And to our eyes, that really does look quite old-fashioned and out of date these days. But it's there if you want to go back to that look and feel. If you want to get it back, you go back under Window and switch to Ribbon Toolbar, and then you get back the new look. I'm just going to flick back into the PowerPoint again now. Again, just to emphasize a few specific things. The symbol outline, which you can see there, was a relatively small change, but I think with some plot types, it makes the plots actually look a lot better. I think where it doesn't work would be plots with extremely dense data. Then the plot outlines just all over plot each other and all the points look black. You can't see the color patterns. But nevertheless, if you aren't using a terrible lot of data, then the black outlines can be very effective. And they can be very effective if you've got not too much data, but over plotting data points. The black outlines can make that more apparent where that's happening. And to access that, on the right-hand side toolbar there, or left-hand side these days, if you click on that, there's a little selector there that says outline symbols, and that's all you need to plot. Let's back into full screen. There we go. Okay, moving on. Again, just another new type of plot and GAS. So we've always had the triplot. So there's two new things on here. Both triplots. I've turned the outline symbols on. Again, even for this density of data, it's actually quite effective. You have many more data points than perhaps not. But the plot on the right is actually a centered triplot that uses something called the calculated Barry center of the data to distort, if you like, the plotting of the plot. If you want more details, look in the help file. But in fact, the data on those two triplots is identical, but the centered triplot makes the data far more visible rather than having it rammed down into one corner. And you can get an idea of how the data is stretched, and I say stretched in inverted commas, by looking at the grid lines which move when you center the data. So that's a new plot type. Another type of plot is we can plot directional data in the three-dimensional drill hole type plot. You might say, why would you want to do that? Well, if you have ioGAS connected into IMDEX Hub and you're using our magnetic survey tool, the EasyTrack, the EasyTrack records in its QC data the mag XYZ relative to north and up and down. So if you connect gas into the IMDEX Hub and you pull down the mag survey data, all of that metadata comes through into gas, and it means you're able to resolve the direction of the Earth's field at the survey stations down the drill holes. And so in fact, it's really quite a, I suppose, complex geophysical interpretation plot, if you like. Another interesting use of a plot like that is you could, for example, if you're doing a principal components analysis, plot the first 3 principal component scores as X, Y, Z directions and view them as a vector down hole. Now, I'll leave that one up to the users, but that can give you a very interesting spatial indication of how your data is varying in a multivariate sense across the drill holes. A little visualization aid here is that we can now color the data in the grid view by percentile. There's the button to access that as indicated in the slide there over on the right. You can either color all of the numeric columns or all of the selection columns in the data set. Those colors there are the same, what we call our geochem percentile levels and colors that we apply by default in the gridding and imaging. So it's a progressive percentile selection, so 30, 60, 80, 90, 95, 97 and a half, I think, how the percentiles go. So that's how they're colored. So again, it's almost like a visual guide to how the data are correlated, looking at the raw variables. Of course, we always encourage people to look at the raw data, not just the outcomes. A couple of data manipulation tools here, which one's been improved and one is new. So appending data to the end of a gas file used to completely rely on name matching. Now with appending data, we can alias new data that you append at the same time. So it might not completely match by name, but if you are appending FE% to an FE203% column, you can adjust that alias on the way through. So that makes that append much more useful. But we've also brought in the ability now to join columns on the end of the file, or sorry, on the side of the file, if you like, using it's a relatively simple joining concept, and the logical joining field to use in most instances, or with most people that use gas, would be the sample ID field, because you all have unique sample IDs in your data, I assume. And some of the workflows that opens up is that, and because we do know that people either have data from outside of gas they want to bring in and match, typically with geochem data, or the other workflow is that people, users may take data out of gas and do some sort of other statistical manipulation with it, but then want to get it back into gas to do the visualization of the results. So the 2 use cases there would be, for example, using Sasha Ponchor's AI Siri software from AusSpec. We know that a lot of people have chemical data, chemistry data for their samples. They also have spectral data. A lot of people now run it through AI Siri to get the mineral ID and the mineral association IDs. If you want to get the spectral results against the geochem data, that's now an extremely simple process to bring that in and work them together. Similarly, if you were to export some of the raw data out of gas into something like R and apply a high-level statistical routine, bringing those data back into gas using the sample number join to complete your visualization is also now a much easier task. So we've done that. Lots of users have been asking for that for a few years, so we've finally put it in. We've upgraded the calculation engine. It looks a bit different now when you open it. All I can say here is we don't have time to go into the precise differences between how it was and what it looks like now. It is compatible with whatever calculations you've created in the past, but it is in fact now more powerful. We highly recommend that if you want to take advantages of the advanced features of the new calculation engine, that you, do we have to say it, but if you just go and read the help file, because it is fully described in there. One of the reasons we changed the calculation engine was so that it can reference the outcomes of previous calculations. So in shorthand, we call that calcs within calcs. Now, we are sure people will put this to all sorts of strange uses, but one of the first uses we've put it to ourselves and actually ship it with gas is the ability to calculate CIPW norms. So we've put in a fairly classical version of the CIPW norm calculation, but given the structure, the way we wrote the new calculation engine is that rather than us write that in code, it is just a calculation object, which means that you can write your own normative type calculations, if you like, using the same tool. And of course, if you can run something like a CIPW norm, it means then you can access the ioGAS volcanic rock classification diagram, the QAP diagram, directly within GAS. So you can bring your geochem data in, run the CIPW norm, and plot the data immediately on the rock classification diagram based on the normative mineralogy, and push those classifications through into the data and look at them spatially. So we've vastly improved that workflow. And of course, you're able to, if you have 10, 100 or 100,000 rock analyses you want to apply this analysis to, it's the same amount of work to do it now in GAS. Another thing which Putra mentioned quickly, but this is actually a fairly cool feature, and so I just wanted to bring it up again, is the ability to write the normalized. So after you've made a spider plot, of course, the elements that appear on the spider plot are all normalized to some reference value. So whether it be crustal abundance, various rare earth element normalizations with MORBs and things like that, there is a normalization involved. What you can do within GAS now to make spider plot concept more useful is that when you make a spider plot, so you've normalized your data to something, you can now select which of the elements you're plotting on the spider plot back into the data file in their normalized form. So you're just looking at that dialog there on the screen. So barium is ticked there, for example. So writing barium back into the file in this case would be barium divided by the crustal abundance of barium in the Earth's crust, so it'd be times background. Now, that alone is a bit useful, but what makes it even more useful is that in our thematic maps or our variable maps, we've now included a new thematic operation. So you go back to the spider plot, you might be normalizing your data to crustal abundance. You elect to write the values, in this case, arsenic, barium, chrome, copper, back into the file. You can then select those normalized components, let's call them times background, select them, make a variable map, but then in the thematic options here, you can actually pick a fixed range of coloring and sizing schemes. So in this case, it's very easy to pick multiple elements and then make thematic maps of those elements, thematic that 2, 5, 10 or greater than 10 times the abundance or whatever you normalize the data to. Now, from an exploration geochemistry point of view, that is cool because you can go through all of your indicator elements, normalize them to something very quickly, and look at a pile of normalized times background maps in a matter of a couple of minutes. Now, that's not our idea, at least actually. So Scott Halley suggested that to us a couple of years ago. So Scott, if you're listening to this at some point, there's your idea in action. Some interoperability things. So we've released the ArcGIS Pro plugin that's up on the website already. So please feel free to grab that whenever you want and install it and run it. But new within ioGAS version 7 is we've built in the acquire link. And this means that, in fact, it's not in progress anymore, it's complete. The acquire link you can access from within GAS up on the ribbon toolbar under the file menu, I think, or data menu. And it pulls up a dialog that allows you to configure what project you want, what type of data in the project, which is really quite powerful. Previously, with people running GAS, they might be using ODBC type connections to hit on a view that a DBA had created in Acquire. You can bypass all of that now and just go straight into acquire and get the data directly without needing to bug your friendly DBA. And a couple of small things just to finish off here. One at the top there, so although LOI isn't strictly an element, it's now part of our mineral composition library, and it is possible to have LOI on a triplot or a scatter plot or elsewhere and plot mineral nodes against that. So for example, things like goethite and kaolinite are plottable when you have an LOI for them and LOI is on the graph. There's a new type of regression, reduced major axis regression, RMA. There's not a lot of information about it here, but really the key thing about this versus the normal least squares approaches is you can have error in both the X and Y variables. And often if you're doing calibrations or geochemical type work, we virtually always have error in both the X and Y axis. So doing a reduced major axis regression often makes more sense. And the other thing which makes it a bit easier for geologists to comprehend is that the equation is the same no matter which way around you have the X and Y variables, because you're minimizing the distance from the data point to the line of best fit in both the X and Y directions, not just parallel to the Y axis. So that's another new bit in gas. I've just covered off that one. Putra covered off depausing. So that's mainly useful when you have an extremely large data set, if you're just clicking around ad hoc, changing visibilities and colors and ramps. It can take a while for all the plots to update. This is a convenience thing. You can just go and set all of those things and then apply them in one go. It makes it a bit more efficient. And for those of you who are really dabbling in large data files, we've now constructed a few builds of gas which can take advantage of a lot more RAM. And down in the red box there in the installation directory of where gas is, you can see there's a 24G version. So that means gas can occupy 24 gig of RAM and read data in. That is sometimes useful. That makes things like pausing updates useful. It also makes things like the random data selection within gas useful. And don't forget that if you're really trying to pull in enormous data sets off a disk into gas, there is a tool in gas which can look at the file before it brings it in and pick a random selection of that data. That is anathema, of course, in exploration. But if you're looking at giant block models and looking at modeling trends, then that is quite a valid workflow. So you may elect to, rather than pull in 40 million rows of estimated parameters in a block model, you might tell gas to go and give you 10% of that data, so 4 million values, and bring them in and then work with them. That then becomes quite an efficient workflow. So thanks for your time. I'll just check with Leah to see if anyone's asked a question or typed the question in, so there's none there. If there's no questions, that's fine. This webinar has been recorded and it's going to go onto the website. So if you have any colleagues that you think should watch this, just to get a quick update, it'll be there next week. Next week. We're going to run this again this afternoon, 3:30 Perth time. If there's someone running around the office and thinks you'd see it. And we're also going to do a translation of the webinar into Spanish as well. And that will go onto the website. Probably not early next week, but in the not too distant future, we'll have a Spanish overlay. So thanks for your time, everyone. As usual, please send us any feedback. We are very interested in any feedback anyone has on the ribbon toolbar. The normal email addresses and contact names are all there within GAS. Please feel free to use them, and have a good rest of the day or evening.